So the next video that you need to watch is this one about increasing and decreasing of functions in the graphical analysis. So I think this is the toughest one, so you might need to watch it more than once or make sure you take really good notes and then come in with questions for class the next day. For increasing and decreasing, the important thing to remember is that on what x interval are your y values increasing or decreasing. So your answers are always going to be intervals of the x-axis, saying my y values are increasing on this x interval, or my y values are decreasing on this x interval. So you're never going to write down y values for your solution. So let's start by looking at a basic quadratic x squared graph. So as you can see here, the graph goes down and then hits a spot, and you know that this is an absolute minimum, and then it turns and goes back up. So on what x interval is this graph decreasing? Well, since we know this graph goes on and on forever, on the x interval negative infinity, so it is decreasing from negative infinity to 0. Now we use parentheses for the 0 because at 0 it's neither increasing or decreasing. It's a moment where it's static for 1 second and then it turns to go to increase. So right now on what x interval, all the way from negative infinity until we get to 0, the y values of this graph are going down. Now once we hit 0, then our y values start to increase. As you can see, the graph goes back up. So we're going to increase from 0, just past 0 is when the graph starts to go back up, to infinity on the x-axis. So from 0 to infinity, the y values are going to continue to go up and up and up. Now let's take a look at a different graph. Let's make this x to the third. How is that going to change? You guys know the shape of an x to the third graph. So as you can see here, this graph never decreases. As you work your way left to right on the x-axis, the y values are continuously going up and up and up and up. Think of it as a roller coaster. Are you going up the roller coaster or are you going down? Well, in an x to the third graph, you're constantly going up and up and up. The graph never turns to go back down. There are no maxes in which it causes the graph to switch from increasing to decreasing. So for x to the third, we are always increasing, and the interval in which we're increasing is all real numbers. The graph, the y values are never going down as you work your way left to right on the x-axis. Okay, how about an absolute value graph? What about the absolute value of x minus 6? So here's your curve, x minus 6. You guys know that this point here, let's see if it will let me click it, 6, 0 is our absolute minimum. And as we work our way left to right, you can see that the graph is going down. Our y values are decreasing. So we actually start out decreasing here, and we decrease from negative infinity on the x-axis all the way until we get to this low spot, and the low spot is our minimum of 6, 0. So the x-coordinate is 6. Then once we passed 6, we start to increase, and we increase from 6 to infinity. There's no other point on this curve where it turns and starts to go back down. You just go up and up and up and up and up and up and up. Okay? So let's look at one that's a little more complicated. A cubic function that's more complicated than the one we looked at before, x to the third, and then minus 2x. So if we zoom in, we can see here that we have a local min and a local max. So that means we have an area in which our graph is increasing, then we reach this local maximum, and then we go down until we reach our local minimum, and then we go back up. So for this problem, we're actually going to have 2 intervals where we're increasing and 1 interval where we're decreasing. So working our way left to right, we start out by increasing. So we increase from negative infinity on the x-axis until we hit the point negative 0.816 on the x-axis. That's when our y values take a break and start to decrease after that. So then from negative 0.816 on the x-axis to positive 0.816, you can see that our y values are going down. Now once we hit 0.86, there's a local minimum here and it turns and our graph starts to increase again. So we need to go back up to increasing and add another interval from 0.86, from 0.816, sorry, to infinity. It keeps, once we reach this point, it just goes up and up and up forever, and you can zoom out and see that. So it does get a little tricky once you start to have local mins and maxes, and you'll have multiple intervals of increasing and decreasing. Now the log curve is one that you know the shape of, but you don't know much about the function yet. But let's take a look at the graph and decide, where is this graph increasing, where is this graph decreasing? So as you can see, this graph approaches, it has an asymptote here, so it never actually hits that value. But as you work your way left to right, the values are getting greater and greater and greater and greater and greater and greater and greater. Now we can't say that it is increasing from negative infinity to infinity because there are no x values over here. The lowest possible x value for this function is just past 0, and it can't actually include 0. Because if you take the log of 0, you will get an error. So we are increasing from 0 to infinity on this problem. Okay, so that's your quick lesson on increasing and decreasing. You have one more video to watch, and then feel free to come in and ask me questions.